Welcome to solverfy.
Hydraulic press looks something like this. There is a fluid which has two pistons on both sides with wildly different areas. What you do is you apply some force F on the piston with the smaller surface area. Let's say the area here is A and the force here is small f. The pressure will be F by A. Now this pressure will propagate through the liquid and hit the other piston. So the pressure here will also be F by A, but because the area of the piston is larger, the force will be pressure times area. So pressure times area, which will be F by A times A. Now by making capital A much larger than small a, we can make the force here much larger than this force. So a simple person pushing down this piston can lift a whole car here, or let's say a whole mountain. That is an exaggeration, but for fun's sake. Now, how is the conservation of energy not violated here? The answer lies in work. Conservation of energy applies for energy, which means the amount of work done by this person should be equal to the amount of energy gained by this weight. That is it. So because the surface area of this piston is much smaller, let's say if he moves it by a distance small x, let's say now the volume of water that has been displaced will be area times x, which will lift the other piston. Now let's say if it moves up by distance capital X. Now the volume of the water that vanished here must be equal to the amount of water that appeared here, and that volume will be area times distance again, so that's area times distance. Therefore X will be X times A by A, which means force increases by a factor of A by A, whereas displacement decreases by the factor of A by A. If you remember, work is force times displacement. That is, so for on the left hand side, it will be equal to FA by A times our capital X is small x times A by A. If you notice, this cancels to exactly the amount of work done by the person. This is how conservation of energy is still conserved.